I would like to build a Wobbler engine, because I would like to build a Wobbler engine. And of course also because I never made one. So this is not a how-to video, but this is a video. This is a flywheel and a cylinder from a failed project. So maybe I can reuse, we'll see. I have a very nice stand here and a base plate. So no more blah blah. Let's start with the I did these two little surfaces here in the milling machine. Of course I can do it on the shaper too, but I have to swing the vise 90 degrees. And the milling machine was set up as you see it here now. So it was ready to go, so this was much faster. Let's drill holes. Okay, first part finished. Now, what is the idea? This will be the standing up part thing. This is the cylinder, and I have a nice little piston. It's a really nice fit in here. I have to plug these holes because I don't need. And this will come over here somewhere and wiggle, of course piston inside, and I would like to mount the flywheel on top. Now don't ask me why, I don't know, it's just that I want to mount the flywheel on top, that's all. Right, let's clean up the stand-up part, maybe milling machine this thing off because I don't need. Fly cutter, good finish. And of course I also drilled and tapped these two holes here in this part. But I suppose you already figured it out. Right, so this is where we are. Now, I would like to install the flywheel here on top. And I have two cute little bearings. I think it will be better to use bearings. Normally this kind of little engines, the shaft is running inside this stand here, but because I have bearings, why not use them? When I take both and I put them together, it is more or less the width of my stand here. A tiny bit more, but that will be okay. So let's bore a hole in here. I installed the boring head, but the hole I drilled here 16 millimeters. And the smallest bore I can make with this tool 19 millimeters. So this will be a 3 millimeter cut, 1.5 each side of course. And I think for this small boring head this is a lot. But let's see what happens. Slow down. It worked. Of course, now I have to bore it out to 26, and this is now almost 20. 6 millimeters to go. I think the finish will be better if I speed it up a bit. 300 RPM. And indeed, it is better, but not much. Without taking any measurements, I was having fun here with my boring head, and I'm boring and one given moment I think, the hole starts to be very big. Maybe I should take my first measurement. And I guess I was very lucky this time. This is a perfect fit. Where are you, bearing? I'm not saying it's a good idea to just start boring and then hope that it works. Not at all. But sometimes just get lucky. I think it's a bit too loose. We'll see. Time to start thinking about the cylinder. I first drilled and tapped these two holes and I installed a little bolt to plug it. And the center bolt here is of course another one, a little bit bigger. Okay, cut it off and clean it up. A very small change of plans over here. Before I'm gonna work the cylinder, maybe it's a good idea to first install my flywheel here somewhere. I have a small eccentric that normally comes here, but I have to shorten this shaft. And from the moment I have these measure points, then I can start working on this one, figuring out the right position. So first, let's shorten this thing here. But before I cut it off, first over to the other lathe. In last week's video, where I was regrinding the chuck jaws using my little pinky here, some of you commented that it should be way easier to hold the jaws in place using a ring, a hollow ring that holds here on the outside of the jaws. Now, there is of course a problem with this idea. I get it, but there is a little problem. First of all, why do we have to hold the jaws in place? When these jaws are not held together, as you can hear, they move. And of course, regrinding parts that are moving, that doesn't work. They not only move up and down, but also in this way. It's a bit complicated to show, but this jaw will be pushed outwards. If I put a workpiece in here and I hold it just on the tips, the jaw will move this way. If I put a ring around here and then tighten to the outside, the jaws will be pushed inwards, which means these three little surfaces that I have to regrind, they will not be parallel. So with the play in these jaws, if I mount my piece in here, the jaws will be, some call it bell mount. I have no idea if it is the correct way to call it, but bell mount. If I put a ring around here and move the jaws out, they will be bell mount, but the other way around. And most of the time we use of course the jaws this way, the part inside, and this is where they have to be parallel. Right, that's it. Now I can cut it off. That seems to work. Now, for the cylinder, in here there is a threaded part. I don't know if the camera will show it, and I don't need it. This piston too long, but the boring in here, the cylinder, goes till down here. Now this piston is a bit hard on the bottom side, but I will fix it later. So first I will cut off these threads here, and then I will determine how much I have to cut off from this side to have the right position. And to do this I could, for example, install my part here in the lathe. The lathe will make a really quick job of cutting this part off. But to do this I need the forge out chuck, and I'm too lazy to install it. I can also do it here in the milling machine, but the boring head is still installed. What's nice with these shorter workpieces like this one, I don't have to speed up the video. This is actual speed. If I cut off 21 millimeter, it will be just fine. Right, that's done. Now this thing should be mounted here somewhere, and then with a bolt through the stand here, so that it can wobble. The problem is that there is not much meat left here to drill. I have here more or less, I don't know, 6 millimeter, and I don't want, of course, the bolt to go through to not disturb the surface in the cylinder here. The wall thickness in the part here is 5.7 millimeters. That's not much. So I'm gonna drill it a little bit less than 5 and hope it will not deform the inner wall of the cylinder here. Let's see. 4.5 millimeter deep. Because of my little tabs here have this little point on all three of them, they didn't go deep enough in this hole. So the number 3 tab, I just cut the point off. What I don't like to do, but sometimes, you know, have to. And slowly but surely it starts to look like something. Of course I have to cut this thing off and make a kind of bushing and all other stuff. But it starts to look like something. Now I think the most delicate part is coming up right now. And that is of course drilling 2 holes in here and 1 hole in the cylinder to allow the air to get in and after a half a turn get out again. And the position and the diameter of these holes is very critical. And because I don't really know what I'm doing here, I try to figure it out. The idea of air in, which will be, of course, at the dead center, is that how you call it? Completely down position. But that's not really possible because the cylinder is straight. So if we give it, for example, a 90-degree angle, and then air out, also 90-degree. I think my theory of a 90-degree offset for the 2 holes here wasn't too far off. Oops. Is that cool or what? I think this is really fun to build and it's not too much work. Of course, I could do a better job of finishing it better and making real bushings everywhere. But for me this was just an exercise. See it more a little bit like a prototype. So now that I know that it works, maybe one day I will make better. And if you're interested in building plans for this kind of little engines, of course I don't have. But I contacted Aid. And Aid, he's so kind to allow me to share the link to his website where he has a ton of different building plans for the simplest engines and a little bit more complicated. And while you're there, of course, subscribe to his channel, so the links are in description.